this is Jim McKeith. Welcome to the session on Windows Phone 7 development using Embarcadero Prism and the Oxygene compiler. In this session, we'll take a look at using Silverlight for Windows Phone 7 to develop Windows Phone 7 applications. We'll build a Twitter client, we'll build some MVVM data-bound applications, and we'll also look at Tombstoning. As you can see from the slide, I work for RimObjects Software. RimObjects is the company that makes the Oxygene compiler, which powers Embarcadero Prism. Here's an agenda of what we're going to cover. I mentioned all these already. The Twitter client is actually in the introduction to Windows Phone 7. The times that you see there are for if you watch this during the replay, you can actually jump to those particular timestamps to watch that particular part of the video. It's only a half-an-hour session, so probably going to go best if you watch it from beginning to end, but that way if you want to jump around, you can be more than welcome to do that. I hope you like to look at code and watch applications run, because this session is almost completely demos. When you only have a half-an-hour session, you really have to get started, and so let's get to it. Go ahead and create a new Windows Phone application here. Just kind of show you around at this, what you can find in here. So under Oxygene for .NET, you're going to select Silverlight for Windows Phone. This is what you're going to use when you're creating typical UI type applications, business applications, if you want to call it that. There's also the XNA Game Studio. You can create Windows Phone games. Windows Phone game, Windows Phone game library, or Windows games. Windows Phone game library. There they are. So these are what, if you're going to create a game for the Windows Phone, you'd use these. So we're going to use the XNA framework, which is Microsoft's graphical framework for building games. But we're going to stick with the Silverlight for Windows Phone. We're going to create a Windows Phone application. If you've installed the 7.1 version of the OS, then you get prompted if you want 7 or 7.1. So come up here, this is the preview or the design surface, and then this is the XAML editor here. The XAML editor, of course, is the code that renders the screen. So you can change things in here. So application title, we'll say it Oxygene application. Oops, I don't want to hit enter there. And it changes over here. And then you can also change things here. So we'll say page name. We'll say Hello World. Okay, so there's two different ways you can edit the contents of this. Because I'm going to switch this to the over-under just because it's a little easier, because I got my font cranked up to make it easier to see here. But the way it works is you declare these containers and then put controls in it. So what we have here is we have a grid that's the layout root, and it's right here. This is the layout root grid. And that grid has a row definition. It has one row that's auto height, which means it's going to be as big as what is in it. And then the other row takes up the rest of the space. So this is the first row we see here, and all of it. Now, if you can see right here, it says auto. So as I mouse over here, you can actually add new rows, and you can say what size you want them to be and stuff like that. Actually, this is going to edit that row. Fixed size, star is a weighted proportion, or auto. So the options there, or you can click and add one of a fixed height automatically. And now if I do this here, you'll see that it added another one there. So these are weighted, so it's star, but it's weighted. So it's going to be whatever's left. I'm just going to go ahead and take that one out and go back to just one. Okay, so it's like it was. So in the grid, we then have a stack panel. Now, a stack panel is a really useful layout mechanism. It has an orientation of either horizontal or vertical. Now, the default here is vertical. So we have a stack panel is what's right here. If I click here, you can see that it gets selected. So it's selected that stack panel. So it's default to vertical. So we have a stack panel, and in the stack panel, we have two text blocks. Now, text blocks are kind of like labels. We have one here that says Oxygene application, another one here that says Hello World. The X name is the name of that panel as far as being able to reference it through code. And the rest of it's pretty straightforward there. Then we have another grid down here that's the content panel. So this area here is one big grid that you can then lay other things out in. So content panels or stack panels are really useful if you put them in vertical orientation. Then you can put a text block within a edit box or text box next to it. So that creates a label next to an edit box that someone's going to type some text into. It's a great way to lay things out. So you're going to oftentimes, like we see here, have these nested. You might have stack panels nested in stack panels, or stack panels nested in grids, laid out in grids, et cetera, et cetera. So there's a lot of ways you can do this layout. And the good thing is if you do the layout right, then when you have your phone changes orientation, you can have it adjust its layout. In your solution, you're going to start out, you have a splash screen image. This is the image that's displayed for just a split second before the application loads. Then you have your application icon, which is a little starburst here, and you have your background, which is the background. I've never actually seen this used, but it's supposed to be the background in the application. Oh, something else that's interesting, and I'll point this out while we're in here. Okay, so this app XAML is the XAML that describes your application. It's kind of like your main program loop in a regular program. It contains information that's used by the rest of the application. So you have an app XAML and a XAML.pass. So the XAML.pass is the code that runs, and then the app XAML's got some not very much information here, but you can put more information here, styles that are used elsewhere, and stuff like that. In here, though, there's something kind of interesting. So this handles all the application launching, activated, deactivated, etc. But also down here, you have this in the constructor. We have this check for debugger is attached. So if the debugger is attached, it's actually going to add a little piece of text along the side that shows the frame rate counter. You can actually change this to show some different things or take things off and stuff like that. So when you're running this in the emulator, you'll see this little bit of text on the side occasionally if the debugger's attached, and that's where that comes from, is right here. Most of the time, it's not a big deal, especially considering that the emulator is when you're running it in the software emulator, it's going to run a lot faster than it will on the actual hardware. So looking at the frame rate now, if that's a big concern, isn't going to be as big a deal. Of course, you can attach the debugger to a device if you have a device hooked up and set up for debugging. So I'm just going to do a really quick sample here, and you'll probably see where this is going here. So we're going to drop down a text box. So a text block is like a label. A text box is an edit box. This one's going to be able to edit. This is a really cool feature of WPF. So we have this whole thing here. This is the anchors. Okay. So I can resize this here, and you notice it's got anchors up top and on the right. So I can take this anchor off. So if I click on it, and it pops over to the right, or you can put anchors on both sides like that. So that means this will automatically expand if it's on a different size phone or different orientation changes, etc. Put a button down. Over in the property editor, we can change the caption. We'll say click me, or content is what the button displays. And we'll go over here to events, and we'll add an on-click event handler. And we will put in here a message box, show, and we'll just display text box 1.text. We'll put a little hello world, or hello, like that. All right, and we'll go ahead and run this in the emulator. I'm going to run it without debugging. And I've got an unknown identifier message box here. I misspelled it. There's too many S's, so go ahead and fix that for me. And try again. Just got to start the emulator the first time. After that, it'll be running it much faster. The emulator gets installed when you install the SDK. So click me. Hello, text box. So I can type my name in here. I thought for sure this used to work with the keyboard, but now you have to actually use this here. Hello, Jim. So I'm not sure if I changed the setting or if that's part of the 7.1 update. So there we go. That's hello world. Really quickly there. Hopefully showed you a little bit of a few of the details on this. You can launch your application from here. You can also uninstall it. Just hold down to uninstall it or pin to your start menu. If you do pin to your start menu, when you change the icon, it doesn't always update. You have to unpin it by unpinning it and then repinning it if you want to see the updated icon. So now I want to show you a simple Twitter application or Twitter client application. This one actually doesn't log in and post and all that stuff. All it does is looks up and shows you somebody's public feed. Public timeline, I guess is the technical term. So in here, what I've done is I've added a list box and a text box and, of course, a button. Beyond that, pretty straightforward here in the UI. In the code portion here, I added support for linked XML, which I believe I had a reference to that. And then I've also created this Twitter item class. So this is just a class that I'm going to put the items in that I pull from the Twitter stream. So then on the lookup button click, all I'm doing here is I'm using the web client to download. Well, first of all, I'm assigning an event handler for the download string completed. And I'm going to use the async call. Now, it's important to use async call because Microsoft has a rule that you cannot block the main UI thread. And so you always have to use the async calls instead of the synchronous calls. Now, what that means is that you're going to assign an event handler like this, and then you're going to make the call. And so this is an asynchronous call. And I'm going to call just user timeline, username, screen name, and then pass in the screen name text from that text box. And when that finishes, it's going to then call this event handler here. So this event handler, first of all, checks to see if there's an error message. If the error message just stops, we could add some error handling somewhere else, but right now we're just going to leave it like that. And this is where the linked XML comes into play. So I'm using an X element here, and I'm just going to parse the results. So the results comes back as an XML because I specified XML here. And it's just going to parse that into a X element collection. So then from that, I can then say, I'm going to assign the list boxes item source. So the item source is the mechanism where you bind items to the list box. So I'm going to use the link to XML here. I'm just going to say the XML tweets, which is this object of collection of X elements from the parse here, created out from parsing. And I'm going to say, get me all the descendants of their statuses. So we're going to get all the status updates. And then we're going to go through each of those tweets, and we're going to create a new Twitter item, which is this class up here that we specified. And we're going to assign the image source. We're just going to parse out the XML here. So we're going to get user profile, image URL, value, put that image source, message, username, put that all in there. So this is going to create it's going to put in a list of Twitter items, which are these classes here, into that list box. That's it. That's all the code we have to write in order to go out and retrieve it. Now, there's actually a little bit more code that's written behind the scenes to bind this in a way that's displayable to the user. So I show you that. That's down here in the XAML. So this is the list box here, and you can see here's my list box highlighted down here. I'm going to make this bigger so you can see this all. So on the list box, I've created an item template. So an item template, which we see right here, is a way to further define what an item in the list box looks like. So in its simplest form, a list box is just a list of strings. Okay, it's just going to display, call toString on any item you bind to it, and just display that toString value in the list. But here, we're actually going to replace that item template. And we're going to say it's a data template. And so because we're data binding it here, I'm pointing with my finger and you can't see that. So here's the data bind. So let me back up here. Data template. And so we're using that stack panel I talked to you about earlier. And the stack panel has an orientation of horizontal. And we're putting inside that stack panel, we're putting an image and then another stack panel next to it. Okay, and then this stack panel, since we're not specifying the orientation, has a vertical orientation. So we're going to have an image on the left, and then we're going to have two texts on the right, one over the top of the other. So the image is the image source from, now see this image source, that is the name of the property here. That's how that works. Have the text block, the text binding is to username, text binding message to the message here. Now, the way the binding works in here is you can bind any property to any property. Okay. So if there was a property in that class that was a color, I could bind it to the foreground color, for example. So here I'm binding it to the source of the image, and here I'm binding it to the text of the text block. And that's really all there is to it. Then I just close the tags up, and that's it. So this is going to, if I don't do this, then it's just going to call toString on each instance of Twitter item to display that. So here I can do this. I'll comment this out, and you can see that. I'll just cut it to the clipboard and hopefully not lose it. So we'll say rem objects, lookup. There it is. So there's Twitter items. So the toString by default is just the class name. Not very useful. So let's go ahead and replace this with that item template, and we'll run it again. It's taking a bit longer than I remember. Okay, there we go. So here is the image source, or the image, which gets the source. That's the icon for the user, and then their name, their screen name, and their message. And that's it. By default, Twitter only gives you back so many. You could add pagination to this if you wanted to, and pull back more items if you wanted to. So this is a simple example of how you use the asynchronous calls, which are required for Silverlight and for Windows Phone 7, as also on how you do the item source binding, which is a pretty much standard function of WPF and WPF, Silverlight, anything that uses XAML. These list boxes are very cool. You can actually do quite a bit with these to bind items to that, and then you can actually put buttons in there, and you can draw things in there, and all sorts of great stuff. You can pretty much put any control over here in a list item, in an item template. And you do that by defining it through XAML. Now we're going to take a look at ModelViewViewModel, or MVVM. ModelViewViewModel is Microsoft's specialized version of MVC, or Model View Controller, for use with XAML. So it's for use with WPF, Silverlight, and Silverlight for Windows Phone 7. The model is your data, your object model, your data access layer. The view is the graphical user interface, the GUI, the buttons, the grid, the list box, etc. And then the view model is the binding between the model and the view. So the idea behind ModelViewViewModel is you want to get the data and the binding out of the view. So that's not in the user interface code. That's really all there is to ModelViewViewModel. Essentially what you do is you have a new class that you've created that you move the data, holding the data and the binding into. And we'll take a look at that. Here's a Oxygene Windows Phone 7 application that implements the ModelViewViewModel pattern. I'm going to show you how this is put together and what makes it work. I'm going to go ahead and switch this to landscape mode. And I have to click here. This adds the to the XAML here that it supports landscape. It looks a little better here in the designer for this presentation. So first of all, you see you have some design time data here. Okay, the design time data actually comes from right here. This D data context loads design data from this file right here. And actually, before I jump to that file, this data is displayed, as we saw earlier, using a data template. Okay, so it's displaying line 1 and line 2 from the items that it's bound to. Okay, so this here is a XAML file that is essentially a serialization of the item view model, or actually it's a serialization of the main view model, which contains a collection of item view models. And you'll see here it has 1, 2, 3 lines of data, but yet in the design time view, we only saw the first 2 lines. So the third line, for example, here is going to be the detail data. So let's take a look at the main view model. The main view model this is what holds the collection here of item view models. This is what holds the data. So this also knows if the data has been loaded and how to load the data. And we'll look here at the load data is just creating an instance of these objects, because this is a simple example, but this is where you would call to your data model to get the data back. So you have some sort of data access layer or some sort of data model here that would retrieve the data, whether it's from XML or web service or whatever, or data abstract or something like that, something that's going to pull data from an external source, or in this case, it's pulling it from an internal source. So all this is doing is creating instances of these item view models and adding them to the items collection, which is right here. So if we go to our main page XAML.pass file here, in the constructor, it sets the data context to the app view model. So the app view model is in here. This is our app.xaml.pass. And this is just it's the binding. It holds the binding of the main view model object. So all that does is here is we have a property that's exposed, and then the get view model, all the way at the bottom, it just delays the creation of this view model until the last possible minute. And so it's only created once this is read the first time. Once it's read the first time, if it doesn't exist, it creates it and returns that. So in here we also have a loaded handler, and the loaded handler just checks to see if its data has been loaded. If it isn't, then it calls that load data, which we looked at earlier. And then we have a selection change event handler that's bound to the list box there. And it's just going to call the details page here using the navigation service navigate, and it's going to pass in the index of the selected item. Now, depending on the mechanism you're going to use for navigation, you might pass in like an ID of the object that you want to retrieve the details for, or something like that instead. But this is just going to pass the index in here for simplicity. So let's go to the details page here. Let's actually switch to landscape as well. And this one actually will go to the pass file. In here, just overrides the onNavigated2. And in here, we just get the index, a selected index, and we find that. Actually, this would be easier read as integer parse, selected index, and we pass that to we go to the app view model and get the item of that index, and we set that as the data context for this page. So that's how the view model is implemented here. So we'll go to the files again. Here we have the sample data file, which would be replaced by your data access layer or whatever mechanism you're using to get data into your application. And then we have the view models. So we have an item view model and a main view model. The main view model is the one that's used by the main page, and the item view model is the view model that's within, what the main view model has a collection of is the item view model. Then we have our main page and our detail page, which these are the views. They are the user interface. So really the big difference between the non-MVVM way of doing things is the non-MVVM way of doing things would have the collection of the data in here someplace. Okay, so that's putting your data, your model, in your view, and that's what you're trying to get away from here. So this just pulls the data out of here, out of your view, and puts it into these view models. So let's go ahead and run this. So there we go. There's all of our things here. Now, if you noticed in here, we only have 6 items, and they're named design. But at runtime here, they're named runtime, and that's because they're pulled from the actual data source, which is main view model. And so here they're given runtime and the number. That's just so you can see the difference. So we scroll through, here's all our items, and we select an item, and we go to the detail view. And so each detail view is different, but this is just lorem ipsum, so it's not really very interesting. Oh, that's 11 again. Here's 12. See, it's got a different value in here. So there we go. That is the MVVM, which is Microsoft's recommended way of putting data in your application, how to make a data-bound application, recommended by Microsoft. And since I enabled landscape mode as well as portrait mode, I'll go ahead and show you that here. Here's landscape rotating through. We're back in our Twitter application to explain tombstoning. Tombstoning is how the Windows Phone deals with being deactivated. When an application is deactivated, it actually terminates the application, but there's a couple of events that fire in order for you to deal with that. So let me go ahead and demonstrate here. Right now I have some tweets loaded, and when I press the home button, it's going to deactivate my application, which kills it. Now I hit the back button, it's going to go back to the application again, and all the state's gone. So let me show you how to fix that. It's actually quite easy. I've modified the Twitter application to use the ModelViewViewModel framework, like we did with our ModelViewViewModel example. I've added a main view model, a Twitter item view model, which is the individual items, the tweets, and also added in the main XAML.pass, I've added the view model in here. On application, activate and deactivate. Okay, so this is when you hit the home button, the application is deactivated. And then when you go back into the application with the back button, it's reactivated again. So all we need to do is we take advantage of the phone application services current state. And what this is a dictionary that we can store values into. The key view model is just a constant I've defined that's what I'm going to use for the key to find my view model that I've stored in there, my main view model. So now I'm going to run the application.
And I use here, OBJECDS.
Here is our tweets. I hit the home button. The deactivate fired, so it stored the view model in the dictionary, and there it is in the state dictionary. Reloaded it again. But now, this is the thing that's kind of interesting about Windows Phone 7 development. If I hit the back button from here, this will actually close the application. Because if I hit the back button again, it's not going to go back into my application because I've gone back from before my application was running, if that makes sense. So I can relaunch it by coming in here and going into my Twitter application, but now my data is gone. And that's because the state is not maintained between application sessions. It's only maintained when the application is deactivated and then activated again. Don't worry, there's a solution for this too. On closing, all we have to do is persist the state using the isolated storage. So I have a data.txt file here that's in the isolated storage, and all I'm going to do is use serialization to stream my view model out into that file in the isolated storage. Somehow that got unindented. Okay, there we go. Much better. So we're just getting the isolated storage here, getting a stream, serializing, getting a serializer, and then serializing the main view model into that stream. We're using the using statements here in order to automatically close and free those because they are file handles are involved there. So you have to make sure those get cleaned up when you're done. Now in the launching, we have to reload that again from the isolated storage. So launching happens when it's first launched, not when it's reactivated again. So here we do the same thing. We get the isolated storage store, and then we get a stream using the same file name. And we get a stream reader. Then we spin through that stream using the serializer to deserialize it back into the main view model. When we're done, we're going to go ahead and remove that store because we don't need it anymore. Otherwise, well, I guess you don't have to because you're rewriting it when it closes, but This is something I like to do because then if I close my application, because I'm debugging it, I don't have some funky data hanging out in there. And that's another good point, is that this is persisted between debugging sessions. And so if you change your model here and then try and stream it back in, you might get some strange data results. So you'll want to make sure you clean out your isolated storage if you do change your model. So then here I just check to see if we actually did read an item back in. And if we did, then we persist it and then we assign it to the data context. So we'll go ahead and run this again. And of course, there was no data persisted previously. And we have our data loaded. So now when I close it by hitting the back button and relaunch it again, ta-da, our data is still there. So now we've looked at both ways of persisting the data using the phone state as well as the isolated storage. You can additionally persist the scroll bar location as well as if you have multiple pages using the same technique I showed you. Also, keep in mind that the isolated storage persists between debugging sessions. So close the phone, reopen the phone, etc. Isolated storage will still be there. So if you have, if you're not expecting that later on, it can create issues for you. It is odd that you have to do it both directions, both using the isolated storage and the state for when it's deactivated versus when it's closed and reopened. But that's the way it works with the Windows Phone 7 device. I hope you learned something today on our session on Windows Phone 7 development. If you would like some more information on Oxygene language, visit oxygenlanguage.com or wiki.oxygenlanguage.com. Also, there is one video on Windows Phone 7, although I think I covered most all of it in this session, at rimobjects.com/tv/oxygen. And of course, feel free to send me an email, jim@rimobjects.com, and you may also follow me on Twitter. That would be great. And I guess now it's time for some questions.